Hi, I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of algebra within the Year 11 standard course, and we're looking at formula and equations, which comes under the syllabus topic of MSA1. So in this video, we're going to have a look at what linear equations are and how to solve an equation. So linear equations are equations where it could be a plus 3 equals 7, and you have to solve for a. So a linear equation is where you have one number missing, which is denoted by a letter or a pronumeral, and you need to solve this equation to find what number this letter represents. So to solve an equation, your first step is to perform the opposite operation. So if we want to get a by itself, it's essentially what we're trying to do, we have to perform opposite operations. So to get a by itself, we need to get rid of this 3. And to get rid of that 3, we're going to do the opposite. So if it's plus 3 here, we're going to minus 3, because 3 minus 3 is going to give us 0. So that means a will be by itself. But if we take away 3 from this side of the equation, from the left side of the equation, we have to add it to the right side of the equation, to the right side of the equal sign. So we're going to then minus 3 from this side. So then a is going to equal 7 minus 3, because we add the negative 3 to the other side. Then we can solve. A equals 7 minus 3. We can do that easily. A equals 4, because 7 minus 3 is 4. Then if we were to check this, 4 plus 3 gives us 7. So what we're doing is performing the opposite side, the opposite operation to take it to the other side. So you can add or subtract. So if it's addition, you subtract. If it's subtraction, you add. So you do the opposite. So the opposite of plus is minus. The opposite of multiplication is division. And to solve the 2 or 3 step equations, you repeat the steps as many times as possible to get a by itself. Or another one is squared becomes square root. So when you are solving a linear equation, in other terms, it's saying get the letter by itself. So we want a to be out the front of our equal sign by itself. So that means that a will equal something, and whatever that number a equals or x equals, that's what that letter is representing. So let's have a go at doing some questions where we follow these rules. So you do the opposite operation. If it's add, you subtract. If it's multiply, you divide. And then you repeat these steps as many times as possible, as necessary, to get the letter by itself out the front to solve that equation. So let's have a look at the first one. The first equation, we have 5 equals 3x plus 7. We know that we want to get x by itself out the front. So we're going to do some steps to get x by itself. So first thing what we're going to do is I'm going to get rid of this positive 7. So to get rid of that positive 7, we have to do the opposite. So if it's plus 7 here, we're going to minus 7 to make it 0. And if we minus 7 from this side, we have to minus 7 from the other side. So that's going to leave us with 5 minus 7 equals 3x. So we are one step closer to getting x by itself. We just have to get rid of the 3 now, and then x will be by itself. So 5 minus 7 is going to leave us with negative 2 equals 3x. And now when we are at this stage here, we can see that the last thing we have to do is get rid of this 3. And you might think, how do we get rid of that 3? There's no times, there's no divide symbol, there's no plus symbol, there's no minus symbol. So how do we know what to do? Well, when there is a grouping like this of 3x and there's nothing in between here, no symbol like plus or minus in between, we pretend we know that there is a times symbol in between. So if it's ever written like 4y or 5t, it's just 4 times y and 5 times t. Just pretend there's a little times symbol in between there. So knowing that, we can tell that this equation means that we have a times symbol here. So we have to do the opposite of times, and the opposite of times is going to be divide. So we're going to divide by 3 on that side, and whatever you do to that side, you have to do to the opposite, the other side when you take it over. So if we do it to this side, we're going to get -2 divided by 3, -2 on 3, and that's going to leave us with x. So x then, therefore, x is going to equal -2 on 3. And that would be our answer. So let's have a go at doing some more equations. So here we have a different equation. This one involves fractions. So we have, to solve for m, we have to get m by itself. We've got m on 3 minus 5 equals -2. So let's have a go. The first thing that we are going to do when we have a question like this is we are going to get rid of our fraction, because the fraction is another level that we don't want. We want to get rid of the fraction, so that would be the first thing to do, because once we get rid of the fraction, they're all on the same level. So the first thing we got to do is, if this is divide, we're going to times by 3, and we times everything but itself by 3. So this is a little bit different. You're not just going to times the other side. You're going to times everything but itself. Because if this is over 1 and this is over 1 and that's over 3, we're wanting to change it so that they're all the same. So we have to times everything but itself by 3. So then we will be left with m minus 5 times 3 equals -2 times 3. So remember, when you have a fraction like this and you want to get them all to be on the same level, you times everything but itself by 3. So then we have m, if we expand that out, m minus 15, because 5 times 3 is 15, equals -2 times 3, which is going to leave us with -6. So now we're a couple of steps closer to getting m by itself. I'm just going to go up here so we have more room. The last thing to do to get m by itself is we've got to get rid of this 15. We've got to move it to the other side. So we're going to do the opposite. We're going to plus 15 to this side to make it 0, which means we've got to plus 15 to the other side. So that means we'll have m equals -6 plus 15. And if you put that into your calculator, you get m to equal 9. So we have a couple of different steps there to get our answer. The only trick in this one is to remember that when you're doing a fraction like this, you times everything but itself by 3. So you ignore that and you times that by 3 and times that by 3 and get rid of the 3 on the bottom. So let's have a go at doing one more example. So this one is similar to the other one. We have fractions here, except this time we have 2 fractions. So you're going to have to use some of your knowledge of fractions that you probably learnt in year 6 or year 7 to apply to this question. So I'm going to rewrite the question. We have y on 3 minus y on 7 equals 2. So we have to figure out what y equals. So first thing to do when you have fractions with different denominators is that you need to get the lowest common denominator. You want to get a common number on the bottom. So common denominator. So if we have a think, the common number that goes into 3 and 7 is going to be 21. So we want to get these numbers down here to equal 21. So 3 times 7 is going to give us 21, and 7 times 3 is going to give us 21. But whatever you do to the bottom, you have to do to the top. So if we times the bottom by 7, we have to times the top by 7. And if we times the bottom by 3, we have to times the top by 3. So when you're doing fractions, you have to change the denominator to be a common denominator. Whatever you do to the bottom, or to the denominator, you have to do to the top. So now we can expand that out. So we have y times 7, which we're going to write as 7y over 3 times 7, which is 21, minus y times 3, which is going to be 3y over 21, equals 2. Now when you've got your fractions like this and they're the same denominator, you can just pretend that the line goes all the way across like that, and that the denominator stays the same. So that means that we now have 7y minus 3y on 21 equals 2. So the denominator stays the same. You don't minus the denominator. You don't do 21 minus 21. It just stays the same. It just stays as 21. That's why I crossed out 1, because we only need one denominator. We just need the same, which is 21. So now we have a fraction like we did before. We need to get this 2 on 1 to be the same as on the same level as our 7y minus 3y on 21. So we're going to times everything but itself by 21. So let's go ahead and do that. If we don't times this by 21, we only times this, everything but itself, by 21. So then we get a new answer of 7y minus 3y equals 42. Now we can minus these out. So then we have 7y minus 3y is 4y equals 42. And now we've got one last step to do before we have y by itself. And it's a times here. So we've got to divide by 4 on this side. So we're going to divide by 4 on that side. So then finally, where should we do it? We'll do it up here. Finally, y is going to equal 42 on 4, which is 10.5. So that's our final linear equation example. It's where we have fractions. So remember, when you have two fractions, get a common denominator. So you times the numbers to get a common denominator. Whatever you times by the bottom, you times by the top. Then you can, when you have common denominators, you can keep the denominator the same. So keep it as 21. And then you can minus across the top. And then you can remember that when we get to this stage here, we want to get rid of this fraction part so that it's all flat, that there's no more fractions there. So we times everything but itself by 21. So we didn't times the 7y minus 3y by 21. We just times the other number 2 by 21. And then we subtracted, then we divided, and we got our answer to be y equals 10.5.